Over the course of the next 10 minutes, I'm going to share two stories of project development with you. One is what you're probably expecting, the evolution of a climate action planning web application. But if there's anything the MEM taught us, it's that the best sustainability planners are the ones that adapt to the needs of their situation and their community. Although it's true that we developed a functional web application that met my original objectives, my personal storyline shifted away from purely technical development to that of a client, educator, and advisor. Hence, I'll also be sharing the story of me and my team's own evolution over the course of the project. Emissions accounting, or the understanding of an organization's greenhouse gas footprint, has always spoken powerfully to me in addressing global warming and climate change. When fossil fuels like coal, oil, gasoline, and natural gas are combusted for energy, they release carbon dioxide, methane, and nitrous oxide that get trapped in the atmosphere and less absorbed by the ocean or plant life on Earth. GHGs are also generated from the decomposition of waste in landfills. Once in the atmosphere, GHGs absorb and emit radiant heat from the sun. The rate that we're generating GHGs is currently double what the Earth is capable of absorbing naturally. Hence, we're seeing an uptick in average global temperature, currently about 1/3 of a degree Fahrenheit every decade. The UN Environmental Program and the IPCC advise that GHG emissions need to be cut by over half by 2030 to avoid a climate tipping point with catastrophic consequences to all planetary systems. Community climate action planning can be very effective in implementing transitions most suited to local needs and behaviors. The assessment of a community's GHG emissions is critical to developing management plans for reductions. Unfortunately, the cost and effort currently associated with completing an emissions assessment is unattainable for most communities, even if they do recognize their climate responsibility. I experienced this firsthand last year performing emissions accounting for both Eagle County and Park City. I soon was faced with the breadth of work performing an emissions inventory entails, specifically the process of collecting the source data, such as kilowatt hours of electricity consumed, vehicle miles traveled, and tons of waste. Thus, I conceived the Tiny Feet Climate Action Planning Toolkit for Communities, an online CAP platform designed to instantly guide communities to the actions that can best help them kick off their CAP process. I would use publicly available data to automatically calculate the carbon footprint for every municipality in Colorado. I would then use that to direct a user community to a menu of climate actions best aligning with the sectors generating the most emissions and addressing the town's co-benefits of need. For the purposes of this estimation, I chose to focus mostly on in-boundary GHG emissions, or those generated within the zip code, city, or county boundary of interest. Therefore, source GHG emissions include the following: natural gas combustion, passenger and freight vehicle miles traveled, landfills, cement or manufacturing facilities, and electricity used. The only out-of-boundary emissions we included is airline transportation. This scope was chosen based on publicly availability of data, as well as areas where local governance has influence. I then chose national and state databases to pull this source data from, including the U.S. Energy Information Administration, EIA, the U.S. EPA, Colorado Department of Transportation. I recognized early on that granularity of publicly available data was not ideal. For example, combustion of fossil fuels for building energy is generally a very high contribution to an overall emissions footprint. However, in Colorado, the amount of electricity or natural gas consumed is only available at the service area level, as shown here. Service areas can cover anywhere from a single town to an entire county. Nevertheless, one purpose of this project was to assess the quality of publicly available data, so I proceeded with project development. It was opportune timing that at this point, a Western computer science senior reached out to me to help develop Tiny Feet for internship credit. Simultaneously, Colorado School of Mines expressed an interest in having their senior engineering students participate in the project for their capstone requirement. After giving them an introduction to climate science, we set to work with populating our emissions model for every municipality across the state of Colorado. Each of the mine students took responsibility for an emission sector to populate. Without going into the specific calculation methodology for each sector, the governing equation of a municipality's total carbon footprint is the sum of all the contributing source sectors where GHG emissions are generated. After each of the Mind students calculated emissions for each sector of interest in Excel, our computer science senior developed a MySQL database to house the source emissions and population data. He then was able to publish a heat map of emissions by municipality using a Google API, which became the first contribution to our website at www.tinyfeet.app. Comparing our total emissions estimation for all of Colorado's municipalities to the Colorado 2015 greenhouse gas inventory demonstrated the gaps in our data across sectors. Not all landfills or industrial facilities report to the EPA. The natural gas utility coverage area map did not include every EIA-listed utility, so those were omitted. We also did not include fugitive emissions generated by the extraction and production of natural gas or emissions generated from agriculture due to the difficulty of quantifying and allocating these emissions. Our estimation came in 40% lower than the state inventory total, which, although not ideal, demonstrates both areas for future consideration and opportunity for expansion of public data access at a state and federal level. Half of the team then moved on to developing the methodology to provide climate action recommendations to user communities. We focused on two key informative sources to provide recommendation insights. Actions were categorized by sector of influence and associated co-benefits, which the user can then filter based on their interest. The other half of the team proceeded to develop the user interface for the web application. We populated the website with instructional language for users, beta tested the website amongst the team, and shared the product with a handful of community representatives for feedback. Now that's the story of the evolution of the web application itself. The other story is one of my own program management evolution throughout the course of the project. Now, I'm not new to the role of project management. In fact, I spent 10 years as a lead manufacturing engineer and program manager for satellites. Yet, development of a web application was a new challenge given that I had almost no prior knowledge of website development. The first semester went pretty smoothly. Even after only a year of emissions accounting experience, I had enough understanding under my belt to identify the best sources of data available online and to educate my team on climate science and emissions accounting fundamentals. The delineation of responsibility was easy. Each of the Mind students took responsibility for a sector to perform emissions calculations for, while Eric focused on developing the database and beginning investigations for web hosting platforms. The second semester was a bit of a different story. My coding experience was almost non-existent before this project, so I crammed a coding course over the winter break and audited a Web App 2 course this past semester. Even the professor, Mark Rubin, commented, "This isn't rocket science, you'll be fine." I wasn't. Fortunately, the team had a computer science major, 2 computer science minors, and a School of Mines technical advisor with innate coding knowledge to help out. My own lack of understanding the computer science element of the project led to management challenges. This model view controller design method of web applications was a great way to delineate team responsibilities, with the caveat that I did not quite grasp the methodology until about a month ago, when it was presented in my web app design class. In the meanwhile, there was misunderstandings amongst the responsibilities of my technical team that I frankly was ineffective at providing guidance to delineate. I expected my undergraduate students to manage the responsibilities amongst themselves, but the reality is that they could have benefited from more succinct direction. My takeaway is to be realistic about my knowledge basis. Managers do not need to be the subject matter experts of their program areas, but they do need a fundamental understanding of the system elements to provide sufficient direction. Also, program management is a balancing act. Understanding the abilities and the needs of your team in order to give an appropriate level direction is key. My technical takeaways are that public data access needs to expand. Public availability data varies drastically by state and specific utility. For example, in California, utilities are required by law to provide public access to energy usage by zip code. The opportunity exists to build policy reform into future project scope to expand data access and substantially increase the estimation accuracy of the Tiny Feet tool. Beyond my own development as a program manager, the team members learned just as much about teamwork and project development as they did climate science and community sustainability, invaluable lessons that will carry over to whatever career paths they pursue. I invite you all to explore our beta testing website at www.tinyfeet.app. Thank you all very much.